Okay. Good morning yet, right? We're still not noon. Um, it's what? It's noon. Oh, good afternoon. Sorry about that. And thank you. Um, I think those of you who've been here before, Gary's been a presenter here before a number of years. And he's always got a very interesting set of presentations, and I always enjoy having Gary W9XT here to do presentations. And how many Superfests has this been for you now? Yeah, he's been to all of them, so, and probably presented at more than half of them. Yeah, more than half of them. So, um, you don't need to hear me talk. You're here to hear Gary. So, Gary, why don't you take it away? And
Okay, thanks very much, Dave. Well, today I'm going to talk about low-band receive antennas for all yards. Now, if you don't know a lot about it, but you've heard about receive antennas, generally you think of beverages that might be 1,000 feet long, and that doesn't fit in most backyards. But there's actually a lot of different types of receive antennas, and some of them are quite small. So hopefully we're going to come across some that maybe will be used to you. So what we're going to talk about here is what are the low bands, the challenges of hearing on the low bands, and how these receive antennas can help you hear better. And hopefully there's one or two in here that might work for you. We'll start with the largest ones and go to the smallest ones. For those who don't know me, I've been licensed for about a little over 50 years. My main interests are contesting, DXing, and building and designing equipment. I went to the University of Wisconsin where I majored in ham radio and got a minor in electrical engineering. I retired from my day job. I was director of electrical engineering for a product line in a major medical company. Somewhere along the line, I built a home project and it got out of control. Some friends wanted some. The ARL found out about it and asked me to write an article at QST and, well, you should sell kits because those are more, and got involved with FCC testing, and the first thing I know, I'm head into business. And so don't let these projects get out of control. It can ruin your life. But I run the thing part-time. I'm having a lot of fun in my, quote, retirement. I'm active in a lot of different organizations. These are currently ones that I have an official position in right now. I've cut back a little bit. And I live just about 20 miles northwest of here. So what are the low bands? Well, generally they're considered 160 through 40 meters. Some people say that 30 meters is kind of there. I consider it a transition band, but it does have a lot of characteristics, and some of the things we'll discuss today here might actually be useful on 30. The low bands are really useful for hams because they're really reliable for short and intermediate distances. That's why you have a lot of nets, a lot of traffic nets are on the low bands because you know that they're going to be open. For reg chews, they're good if you have a schedule with somebody. It's not too far away. That's generally where you're going to put the schedule. If you're a DXer, you can work a lot of DX at night, especially during the winter. And the low sunspot years are a little bit better too. And if you're a contester like me, you need to be on that band if you want to be competitive. And as a contester, I'm always looking for an edge to be a little bit beat my competition. And by having some good low band receive antennas, so I can dig out the weak ones, helps me with my score. So what are the challenges of operating and listening on the low bands? Well, in a word, it's noise. And there's two sources of noise. Perhaps the biggest one is QRN. That's from static. You can have a thunderstorm in Arkansas or a hurricane in the Gulf and completely total the band. You might have static 30 dB over 9 and crash peaks. And it's just very unpleasant to have to try to copy signals, and you may not be able to copy a lot of signals through there. QRM can be a problem. The skip on these bands tend to be shorter, and so you might hear a lot of more guys in the area on that frequency than you would say on 20 or 15, where many of them would skip right over, so you'll hear them. And a growing problem is noise from digital devices, especially switching power supplies. Plasma TVs have been a real problem for some people. Fortunately, those are dying out, and they aren't using that technology now, so that's going away. We've had problems with washing machines. I've heard of cases of people having real problems with just washing machines. A big problem that's potentially on the horizon, and the ARL has got a lot of interest in that, is the wireless chargers for electric vehicles. If you're pumping 15 kilowatts through a coil into your car, you're going to have a lot of harmonics and a lot of energy floating around, and that can be a real problem. So the ARL's got a task force, and they're working on that, because that can be a real challenge for us in the future. So how do we hear through all that noise? Well, receive antennas can be a solution. And as you mentioned before, some of these are pretty large, but some are pretty small. And there's a lot of different types. And if you want to homebrew your own, there's a lot of information, and these books are very good. This is a new book that just came out in the last year or two from the ARL. And of course, Google is your friend if you want to look stuff up. There's a lot of plans and information online if you want to build your own. We'll talk about them more in general, and we won't talk too much about the specifics of how to build your own, because that information's elsewhere and you can look it up at whatever interests you. And there's also, of course, commercial versions for a lot of these. So let's look at the noise and characteristics in antennas. The big key on hearing signals and communications is signal-to-noise ratio. How strong is your signal compared to the background noise, whatever the source of that noise is? If your signal's S9 but the noise is 20 over, you aren't going to hear it very well. If your signal's S1 and the noise level is below S0, you got a good solid signal. So it's always the signal-to-noise ratio that you want to concentrate on. So we have some antennas for receive. Now they don't have gain, but they have directivity. In fact, most of them will have negative gain. Some of them might only be 1% deficient. This receive antenna might be 20 dB below your transmit antenna. But if it attenuates the noise in other directions, that'll improve the signal-noise ratio. You can improve the signal-noise ratio by increasing the signal. Well, you can't really do that. But by decreasing the noise, we can make the signal-to-noise ratio better. So that's the whole key, is to try to cut down the noise from other directions. There's a number of types of receive antennas that are available. Design, beverage, loop types, and small magnetic loops, and that's what we'll talk about today. There's some other ones that are out there, vertical arrays, where they use a number of short verticals, usually 6 to 20 feet tall. They all have preamplifiers and phasing networks, and they can be pretty effective, but they're pretty complex. So we won't talk about those. The Waller flag is supposed to be an excellent one, but those things are a monster. If you make them horizontal, they generally put them up 120 feet. If I had a 120-foot tower, I'd put a big 20-meter beam up, not a receive antenna. Those things are just monsters. But I know people that have them, and they say they're excellent antennas. But hopefully one of these will work in your yard. We'll start with the Beverage antenna. It was developed by an engineer called Harold Beverage. He worked for GE in the 1920s. In that time, they were trying to improve the radio links between the continents. We didn't have satellites. We had some undersea cables, but they were limited. So they were looking at antennas that they could use in the lower frequencies that improve the quality of their systems. And the Beverage is basically a long piece of wire in the direction that you want to hear, with a terminating resistor at the far end. And generally, these are better if there's several wavelengths long on the frequency you want to use. And this is called a wave-type antenna. We'll take a quick look at that. Basically, you have your wire. For ham use, generally these are between 250 and 1,200 feet. We have a terminating resistor at one end and a transformer at the other end that matches the impedance of this antenna, which is around 470 ohms typically, to the impedance of your coax. And how this works is you have a vertical signal coming in, but radio waves and light doesn't travel very well through soil, but the radio waves travel through the soil at a lower velocity because of different lower velocity factor than the part that's in space. The wave gets tilted. It's kind of like the wave's dragging its feet in the dirt. And this wave goes along the wire, and as it does, it induces a voltage because of the difference caused by the tilting. And we generate a current, and the current builds as it gets longer and longer. And we get to the end, goes to the transformer, gets coupled back to your receiver. So signals coming this direction, we hear. The signal coming from the other direction is going to have the same tilting effect, but the current's going to see this nice resistor at the proper impedance and go to ground, so we aren't going to hear that signal. Signals from the side, essentially the wave is going to be equal on the whole thing, so there's no differential voltage, so we have a deep null from the side. So this is a one direction. So if and we want to keep these as straight as possible in the direction that we want to hear in. So if we're studying the transformer and looking at the terminating end, that's the signal, the best direction for your signal for reception, and you'll attenuate the signals in the other directions. Here's a pattern that I modeled. I use Easy Neck. It's 100 for 160. It's a 500 feet long, elevated 7 feet. That's a common height because you want to keep it high enough so that the deer and people don't run into it. 470 ohm termination and a 30 angle. And if I didn't label this, what would this look like? What would you think that pattern is? A beam, a regular Yagi. It looks the same. However, there's one big difference. At the 0 dB level, if this was a Yagi, we'd expect this to be 5, 6, 7 dB gain. But look what the dB gain is at 160, almost a minus 16 dB. So essentially we have a lot of attenuation. But we also have a lot more attenuation of the signals off the side, so we do get a net increase in the signal-to-noise ratio. This is fairly short for 160 meters, so the beam width's pretty wide. It's about 100 degrees. Now, beverages are very broad-banded, so you can use them in all the bands. You don't tune them for the band. 80 meters, you see, now it's longer in number of wavelengths. The quote gain is only down a little over an S unit of 6 dB. The front to back hasn't changed much, and the 3 dB points are down narrower. So this would, if we overlaid the plots, that one would look kind of like that. And we go to 40 meters, now we see we've only lost less than half an S unit. It's a lot more narrower, so it would look more like that. But you see the front to back hasn't changed, but that's a little bit deceiving because this shows the back pattern on 160 meters. As we go higher in frequency, this double lobe here will get changed, and there'll be some smaller spiky ones. There'll be more spikes the higher you go. So you might have some really deep nulls at this angle, but just a little bit more, you might not have quite as much attenuation. But that's what to expect on the beverage for a pattern. A few notes. I said the longer the better, but after a certain point, it doesn't really matter too much. Like, you know, if you're fortunate enough to have the space, probably going over 1,200 feet isn't probably that going to help you that much. You want to keep these things straight, but they are pretty forgiving. If you got a tree in the way, you can do a jog off and then jog back again and get back in your straight line again. If you have this thing going over your driveway and you don't want to get run over, you can bring it up 10 feet and bring it back down again. It's going to be such a short compared to the length compared to the wavelength that it's not going to really affect it. You want to keep it away from metal objects, especially vertical ones, to avoid coupling into the noise into your receive antenna. Now these work better on poor average soil. I had one guy I was talking to, he lived in Florida, and he had really poor luck with his beverages. Well, it turns out he had it right on the water, and at high tide the soil was actually underwater, and so you have all this salt water highly conductive, and it didn't work very well. So, but does anybody here in the Wisconsin QTH have to worry about high tides with seawater? I guess not. So you want to keep it the constant height. Follow the terrain. If your terrain is hilly, just follow the terrain. Mine's about 7, 8 feet. Now, nobody has a perfect condition. Follow the rules as close as you can, but don't let it bother you if you can't do everything perfectly. Beverages just want to work. They just want to work. It's amazing. The way G&M gave a talk at the August QSO Today conference. It's still online if you can find it. But he kind of looked at what some of the situations that are non-optimal. He looked at sloping, what that did. He tried doing zigzag vertically to increase the electrical length, and it was a very interesting talk. If you can dig that, if you don't, send me an email. I might be able to find the link to that. Now, I do produce the components for beverages. You can build your own. You can find the plans out here. have the BT75 transformer and the terminator. These are in NEMA rated cases. They have gaskets on the lids, so they're sealed. I also can formal coat them in case you get some moisture in there to prevent corrosion. Stainless steel hardware. I have gas discharge tubes in there that help protect them from surges. I'll go into more about that. And they're available at Ham Radio Outlet. Now, Ham Radio Outlet hasn't had a lot of inventory here, and they may be out of, if you want to buy some of my stuff, they're out of stock. See Tom, the manager, because I got some more stuff in my car that I can deliver to HRO, and they can sell it if you're interested. Now, we talked about the beverage above ground, but there's also beverage on ground. Some people just lay these on the ground. Now, you don't want to bury it or when it gets covered from snow, it'll be less effective. And if you can raise it a few inches, that's good. I've known one guy who had a stone fence going in the right direction, or a stone pile, and he just laid it on the stones, and that really helped quite a bit. Now, earlier I mentioned how we had the velocity factor of the ground is slower. Well, this essentially allows the wires to be shorter. So you might have a typical length of 250 to 1,200 foot for an elevated beverage, but a beverage on ground are typically 90 to 250 feet. Now, the advantage, you don't require support. It's somewhat stealthier, but it is potentially a trip hazard. The termination is lower. You want to terminate these at 270 ohms instead of 470 ohms like the other ones. Now, you never get anything for free. The signals on a beverage on ground will typically be 10 to 15 dB below an elevated beverage, so you might need a preamp. Nothing's free. Okay, let's look at some of the other ones. There's low band loops. There's a number of different varieties here that you can make. They each have their own little characteristics, and the insulation, one might work better than the other. Now, these don't work like the wave antenna, like the beverage. These look like more like two closely phased verticals. First one we'll talk about is the K9A wire array. It's a very popular array. Gary Reed developed that. He's from Mount Horeb, from in Wisconsin. Really sharp guy on radio stuff, and it was published in September of 97 QST. It's a very good article. If you're an ARL member, you can, of course, get that. It's two diamond-shaped loops. The neat thing about it is it doesn't take much space, about 25 feet, and you can switch it into 4 directions. And there's a pole. You can use a pole. Now, there's somebody in the audience who we will not mention to protect the guilty, but his wife wouldn't let him put up one of these any more antennas, but he was so stealthy he could put it in the trees, and she never did discover this, last I heard. This is what it looks like. Like I said, it's a diamond-shaped antenna. Now, remember in the beverage, if we stood by the transformer and looked to the terminating resistor, that's where the best direction received. This is opposite. If we look from the transformer to the terminating resistor, we're looking in the null direction. Now, if you're really clever and you put in the transformer and the terminating resistor at the base, which isn't drawn very well in the control box, and put in a relay, you can switch. The terminating resistor goes from this side to the other, and the transformer goes to the other side, and now we can instantly switch forward and backward. And if we're a little more ambitious and a little clever, we can put another loop at right angles, another relay in there, and now we've got four directions we can instantly switch. This is the one at my station. I put one up, I don't know, 15, 18 years ago. My pole is made of PVC. It's about 24 feet. I have some shaved down 2x4s, the splices that give it extra strength. This spring it broke. It got cracked down here, and I think it was probably from the UV. After 18 years, it finally broke. I just have a pipe that goes on the ground as a support, and the actual wires act as kind of like guys. So I put it back up again. This time I sprayed it with some plastic paint. We'll see if that helps protect it from UV, so I don't have to go through all the trouble in another 18 years. Maybe I can get 25 out of it, or whatever. You can kind of see the wires, this diamond shape here. This is to the one going to the northeast, the northwest, and one's coming this way. This is the northwest, and that's the southeast. Here's the control, and then the flags in there to hope to keep the deer from running into it. So it doesn't take up very much space. I use RG6 TV coax to feed this. This is an older picture. It's the same box. This is an older version of the switching. This is a newer version that's in there now. I have the relays. Here's a transformer, some terminal strips for the control lines and the coax and the terminator and stuff. This thing here is a gas discharge tube. In the past, I would have problems a lot of times in the fall when I started using these again, that on my K9AY array, and especially my beverages, some years I'd turn the thing on and it was dead. And I'd look at everything and everything looked fine, but what it turned out was something happened to the transformer. I replaced the transformer and it worked fine. Since then I started putting these things on to protect them, and I've not had any failures. I have them in a lot of my products. I've probably had 800 or 900 of these units in the field with these, and I've not had one of them. Somebody mentioned that they had a problem with the thing suddenly just dying. So if you build your own, I suggest you go. They're not very expensive. You can get them from DigiKey or Mauser, and just look for the lowest voltage one that they have available. So this is what's in there right now. This is an experiment. This has about a 470 ohm impedance, but people were talking about varying the resistance for the terminator. So I built a little thing up. I had some relays and some resistors, and I could remotely select about 8 different termination values. And it helps sometimes. It seemed like if the signal is off directly off the back, by playing with that, in some cases I could increase the attenuation off the back on a certain signal. And sometimes it's pretty dramatic, like 15 dB or more, but it didn't happen all that often, and in the upgrade and some other reasons I stopped using. But if you're really looking for ultimate performance in one of these, you might consider looking at that. This is a schematic that I have for the one I built. It differs from the original article in a number of ways. The original article used a tapped coil, single coil with a tap on for the 75 ohm impedance. And everyone pretty much agrees that using separate windings on a binocular toroid coil is a lot less noise. And I found that to be true too. So pretty much everybody uses this sort of a design for their transformer. Here's the gas discharge tube. Here's the relays and the connector to the wires. And if you can go to my personal website here, I've got some more information, so you don't have to worry if you want some more information and a better look here. So Gary's is a different transformer, did not have the gas discharge tube, and he controlled his relays a little bit differently than I did. He basically put a voltage on the lines and some diodes, so if he had plus 12, it would turn on one diode, minus 12, he'd turn on another relay. If you use AC, it would turn on both of them. I've had problems with noise and some of the situations that I've done where I've tried using the control voltages on the coax. If it's done right, it'll work, but if it doesn't right, you can get a lot of noise, and the whole point here is to get rid of noise. So I decided just to use separate control lines. If I'm running a cable over there, I ran some Cat5 along with it, trenching an extra cable, and it was really no big deal. It's only about 100 feet or so to my house where this one is. So I went with that way. You can do it either way, whatever you feel works for you. There's some other loop type antennas that are popular. The flag antenna, the Pennant, they're pretty similar, just different shape. And they've been written up in QST and online in some other locations, so you can do some research on them. They're a little bit different in that the flag antenna and the Pennant tend to be about 8, you want these about 8 feet off the ground, so you need about 25 feet of support here and here. This is about the same. So you'll need a couple supports. Maybe you got trees that'll work fine if they're in the right locations. 1,000 ohm termination. They're pretty broad, about 150 degrees. And again, like the K9AY, the opposite direction. If you're looking at the feed line, you look towards the terminating resistor. On these loop antennas, you're looking at the null direction as opposed to the beverage, which you'd be looking in the forward direction. Two other ones are the U or EWE and the V3DO. This one is essentially an upside down U. You can see it's about 40 feet and 15 feet high. This, my understanding, was just developed by a Scottish ham who also raised sheep. And instead of it calling the normal U, he called it U like the sheep U, as a play on words. The V3DO is very similar, but instead of closing the loop with the ground, he actually brought the wires in here, and you can actually use a single ground rod if you build this one. You notice this one is kind of customized to the band. For 80 meters, it's pretty small. It's only, well, a foot off the ground and the top, so it's only 6 feet high and only 20 feet long, and then it's bigger if you want to use 160. But this is a pretty simple way of getting it if you want a single direction. The last antenna we're going to talk about is the small magnetic loop. Now, these are available commercially. You can build them yourself. I personally have not had a lot of experience, but I know people that have used them and they're pretty happy with them. You can make them circular or square, doesn't really matter. Now, the signal on this is going to be very low, so you're going to need a preamp on this almost for sure. Now, this is bidirectional. It's going to be receiving signals best off the plane of the wire. If you look at the top, the nulls are going to be opposite to the plane of the wire. So it's bidirectional, and it might not be useful if you're trying to work Europe and you've got somebody with a plasma TV to the southwest. This isn't going to help you because it's going to receive that direction as well. But because it's small enough, you can often rotate these. So if you have a noise source from a certain neighbor, maybe you can null them out with this by turning it. I gave this talk a few months ago, an earlier version, to a group in Arizona, and one of the attendees said he built one of these about 6 feet, and he's really happy with it. It really helps him. Now, one of the problems with these antennas, especially like the beverages, is it's kind of tough to rotate a 1,000-foot wire. So what do? Well, one thing you can do is you can make them bidirectional. And there's some ways of making a beverage bidirectional. Generally, they use 2 wires and some more complex transformers, and there's commercial ones in homebrew, and you can look those up. W9XT came up with a system called the BevFlex. Jeff is a really sharp guy. He's got a bunch of patents, and he's in the broadcast industry. He's won all sorts of awards for stuff for like AM broadcasting, whatever. He came up with a system called the BevFlex, and it can be used in beverage and bog configurations. But the antenna is made of RG6, and it's switchable in forward directions. And you can also configure it as switchable flag, EWE, or V3DO. He came to me a couple of years ago and asked me if I'd be interested in manufacturing and selling this, and we talked for a couple of weeks, and I put one up and thought it was a pretty cool product. I made some changes in the design to make it more I have a pretty good background in manufacturing and electronics, so made some changes to take some cost out, make it more reliable and a little less expensive. And they're available at HRO, but they may not have any stock, so if you're interested, you get the manager and I can deliver a couple today. And I've also got a 4-direction version called the BevFlex 4XQ, which is essentially like 2 of these with a switch, so you can put them up in 4 directions. And these are the parts involved. We have terminators at each end, we call a feed unit. We have a control unit, just a switch. Instead of in the beverage, instead of using a wire, we use RG6 coax, and this is the same kind of length, whether it's a bog or elevated beverage that you would use. It works just the same way. The signal travels along the outside of the coax. It gets to the terminal. The terminal has a transformer. It takes the higher impedance signal off the out part of the coax, converts it to 75 ohms, and sends it down into the coax, and then it's picked up, split off here into a switch in the shack. So the coax is the antenna on the outside, and it's part of the feed system on the inside. And there's two of them, so we can get it from both directions. And the really cool thing about it is this feed unit can go anywhere between these. So you can put this normally closer to the house to minimize the amount of feed line that you have to use. But it can also be used for a number like the flag or VE3DO with wires and stuff. You can look, if you go to my website, unitedmicro.com, you can download the manuals and read about all this. But essentially you can make these different types of loop antennas with wire and then use the terminators on there instead of the transformer and the terminator. And you can get the two direction for both of those. So you decide you're going to put up a receive antenna for the low bands. I'm not sure, which one you want to build, but there's a few things you might want to keep in mind. Protecting your receiver, interaction, and feeding preamps, and we'll talk about those one at a time. The first thing is if you run high power, you can damage your receiver and burn out the front end if you aren't careful. So if possible, you want to keep your transmit and receive antennas as far apart as possible. There are protection devices that you can use, or some of them are available commercially. I'm not real familiar with them, but there's two different types. And when these disconnect the antenna, I've used those and built those where essentially you have, it disconnects the antenna, the receive antenna when you're transmitting. Now, if you have a radio that has a separate receiver input, then that's when you have to worry about the damage. If you only have one antenna jack on your radio, then there's devices available where you can build where you actually have a relay. So when you transmit on the transmit antenna, and you have a switch that selects whether you want to receive on the receive antenna or receive on the transmit antenna. And that's one way. There's RF limiters that'll protect the receiver. The BevFlex has some protection devices in the switch, so it'll help a little bit to give some protection. I'm not going to guarantee it's going to, if you run your antennas about 3 feet apart and run a kilowatt, I'm not going to guarantee you're not going to have some problems in that situation. And of course, like any antenna, you want to disconnect it during a storm. Another thing you want to do is you want to keep these antennas away from other metal objects, especially vertical ones, because you can couple noise in. If you have like a vertical with radials, you don't want to run the beverage over the radials if you can help it. Extreme cases, you want to consider detuning your tower or your other transmit antennas on receive to reduce the coupling. Now, you do what you can on this stuff because the near field at 160 meters is very large, and you probably are not going to be able to get your antennas away to absolutely no coupling. A few years ago, I was at a local radio club, and talk was given by a guy who was a consulting engineer to broadcast stations. And AM broadcast stations have a pattern that they have to meet for FCC specifications, so they don't interfere with other AM stations in their cities, in a certain area. So they'll have a pattern. That may change at night. They may be forced to change their pattern at night. Well, they were doing their, I don't know, every year, every 2 years, they had to go back and check the pattern, and they went through and found out that the pattern was out of compliance. So they started searching away, and 2 miles away, somebody put up a cell tower that was distorting the pattern, so he had to go through and detune the tower. It was quite interesting that it would have that effect. So you're not going to get away with this perfectly, so just do the best you can, and you'll still have an improvement. Feeding the receive antennas. A lot of the systems use 75 ohms. That's my favorite, because the RG6 coax is very low loss. I mean, it's designed to work at the gigahertz range for TV signals. It's very inexpensive because they make so much of this stuff, so it's pretty cheap. I go and buy the roll from Menards when they have their 11% off on there. Buy a 500-foot roll. And there are some stuff, I don't have any right now, but they have some that's self-sealing, so if you have critters that decide that coax might be a nice snack, and they cut through the covering, it'll seal itself. Now there's two versions of this. There's the dual shield and the quad shield versions. The older stuff is dual shield. Turned out the cable companies had a hard time meeting FCC leakage specs with the dual shield, so they went to a quad shield. The difference is the dual shield will have a metallized mylar on the shield, and after that they'll have the metal braid. The quad shield puts another layer of mylar over that, and another layer of the braid above that. And it gives it about another 15 dB of shielding, but we're still up there. My rule of thumb, if I had the dual shield laying around, I would probably use that, but if I'm going to buy the new stuff, I would get the quad shield because it's not that more expensive. The one thing you want to watch out for, though, is you want to get the right connectors. If you mix the quad and the connectors with the dual or vice versa, you're going to have a real mess. So make sure you get the connectors that match those. They do have connectors for outdoor use that have gaskets on there. They're a little bit hard to find. Either way, you want to waterproof the connections like any other antenna connection. Sometimes I'm asked, do you need a preamp? And generally not. I've never really felt much of a need for a preamp with the stuff I've got. If you've got an older radio, it might not have the gain, you might consider that. If you have a short beverage on ground, if you have one of the really small loops, then you're probably going to need a preamp. Maybe if you got very long coax. I have an FTDX 5000, and it has some of the newer radios that cover 6 meters. It has a selectable front end extra preamp. It's designed to be used on 6 or 10 meters if the band is really quiet. It might help pull some signals out. You definitely don't want to be running it on the other bands, especially the low bands. But I found if I'm using a receive antenna that just doesn't have enough signal, popping that in there does a good job. So I have never needed to really have another preamp. If you decide you do need a preamp, there's a few things to look for. The first thing they're going to tout is the gain. Gain is easy and cheap to provide, so they say, oh, ours 30 dB. You don't need a lot of gain. 10, 15 dB is probably all you need. If you find one that's variable gain, that's probably even better. Sometimes they'll tell you about the noise figure. If you do UHF, VHF stuff, you talk about the low noise figure. And the reason for that is that the front end of your radio is going to set your noise level. And sometimes the front end of the receiver is going to have more noise than is naturally there. So if you put a good preamp up there with a very low noise, then you overdrive the front end of the radio and you get an improvement. But if your receiver front end has more noise than, say, S9 static, you've got another problem you probably want to look into. So don't worry too much about the noise figure. The one that you really probably want is dynamic range, and that's probably the most expensive, or the most important spec, but unfortunately not a lot of them will specify that. And the reason is you're going to get a lot of loud signals, and you don't want a loud signal nearby causing overload of the preamp and distorting and wiping out the weak signal. So that's the one you would look for. Unfortunately, they don't usually tell you that. If you live near an AM transmitter that's strong, you may need an AM broadcast filter. I'm pretty lucky. My nearest AM station is a local one about 8 miles away. And as a ham, I'm allowed to run 3 times as much power as they are, so they aren't a problem for me. Another problem can be common mode noise. On a properly working transmission line, you're going to have a current flowing on the interconductor in one direction and an equal and opposite current flowing on the inside of the shield in the other direction. And when that happens, the fields cancel. You don't pick up signals. You don't radiate signals. But you can get some common mode currents, and we have current flowing on the interconductor and usually on the outside of the coax as well. And that can introduce a lot of noise. There was a really great YouTube video I found a few years ago where a guy had a spectrum analyzer and he showed the noise and he put some chokes on and you could see the difference. Unfortunately, he seemed to have taken that down because I haven't been able to find it, but it was very impressive how much knocking that out. There's some ways of dealing with that. If you bury your feed line in the ground coming in, that seems to help quite a bit. You can put chokes or ferrite beads or get one of the bigger toroids and put a bunch of wraps and put that either where it comes in the house or next to the radio. One-to-one isolation transformers will break up that common mode. The BevFlex has one-to-one transformers in the feed box and the switch, so that'll knock out a lot of the feed line common mode noise. And again, I'm not a big fan of feeding the control line signals on the coax, because that's another source of potential noise. So in conclusion, the low band receive antenna might be helpful to you, depending on what your operating styles are and your situation. Have realistic expectations. This is not going to turn it in a weak signal to an S9. It's just going to knock the noise down. And the signal will be weaker, but the noise will be less. And again, you can always turn up the volume. It's a signal to noise ratio is what you really want to deal with. A lot of them don't. Oops. A lot of them don't take a lot of space. You can homebrew them. Like I said, there's a lot of information from the ARL books and online. There's commercial versions, both mine and other of my competitors have a lot of different options out there. So pick the best one you can manage, and you know, you don't let the perfect be the enemy of the good. Do the best you can, and you're going to see an improvement. And another thing is, if you have a chance having multiple receive antennas of different types, you'll find, especially like in 160 meters, that one night one antenna will be much better than the next night the other one will be. And sometimes you'll find, not very often, but sometimes you'll find that your transmit antenna is your best receive it. So, but that's pretty rare. One quick thing, I'll show you what I'm doing on my station. I have a tower here, which it's got tri-banner and VHF, and it's got dipoles for 80 and 40. I've got another tower over here. It's a 60-footer. I have a 2-element 40-meter beam. I shunt feed it for 80 meters, a lot of radials. I have an inverted L that goes up to a tree down here and comes to here. And then for receive, down here I've got a K9AY array. I have a regular beverage going towards Europe, and that's going to be converted to a BevFlex. And I have a BevFlex bog over here for the northwest and southeast. Hopefully I'm going to get that elevated. And I've got another northeast southwest BevFlex bog, and this is the one I put up to test to see whether I wanted to manufacture these things. Well, it turned out when I was doing this, there was a de-expedition to Pitcairn Island, VP6R, and I worked them on 160 one morning, and I could not hear them on any other antenna but that bog. That pretty much was the deciding factor that I was going to be doing these antennas. I built my own homebrew switch box, which makes it very convenient for me. I have a direction control. This is one of a switch that I produce. It's designed for receive antennas. It's a 4-to-1 switch. It's waterproof. You can put it outside. I've got one down here, and I've got one in the house. And the control line here for direction switches both this one and the K9AY array at the same time. If I'm contesting, I'm calling CQ. Generally, I'll listen to K9AY because it's broader, and I'll hear stuff off the sides and back. They'll be attenuated, but I can hear that they're here, that they're calling me. So if I'm calling CQ and I hear a weak guy calling me, I'll just switch the directions here and peak them. And many times just having the right selection on the K9AY will bring them in. But if not, then I can just switch between the K9 and the beverage. The beverage is already switched in the right direction. And almost all the time, that'll pull out the ones I can't hear. So that's pretty much how I do it. So if you have any questions, I'll be at my table down the hall here the rest of the day. If you have any more questions about the talk or about my products, please stop by. So we have any questions?
Yeah, okay, hi.
Just a second, get the mic here.
Oh, okay, thank you. Yeah, hi, Gary, great presentation.
Thank you.
The question I have is, what type of wire would you recommend? See, I have a 630-meter antenna. That's the shape of a U, and it's about 25, 30, maybe 40 feet up at some points. It works okay. Good skyway, but not for DX. So that's a whole different thing, but I'm using fencing wire, electrical fencing wire.
Yep.
What would you recommend for wire on these antennas? Thank you.
On the beverage, that's what I use, electric fence wire. I use the aluminum. It stretches a lot. I have used the steel. I'm not sure it makes too much difference, but yeah, the stuff is cheap. I don't know what it costs now, but you buy a quarter-mile spool of that stuff for a tenth the cost that you get, you know, like regular electrical hookup wire.
Comments you made on other antennas in the area. I put up the K9AY, and it didn't seem to be directional.
Really?
It worked as a, you know, brought the signal down and stuff, but it was not directional. And I had dual diamonds and the dual transformers and all. And I don't know, for some reason then I went and read about it a little bit, which I had failed to do before I put it up. And I had one vertical about, 7 feet from it. And then I had a tower vertical about 30, 40 feet from it. And I had an off-center fed dipole about 15 foot from it. And then I had a fan dipole maybe 30 feet from it. And I guess that was the problem.
It's possible. I mean, there might be something else going on. A good way to test these things is to listen to broadcast stations, like during the day. You can go online and do a search like all the AM broadcast stations in Wisconsin and get a whole listing and see their frequency and what direction they are, and you can, you know, tune to them during the day, so you're not going to be getting a lot of skywave and whatever, and it's a good way to see what kind of directivity. I mean, it's possible there's something else wrong. It might be that your antennas are too close.
That's what I concluded,
Yeah.
because they were, one of them almost shared a support. So it just
That might be
that was
might be
too
part of the problem.
obvious once I
There was another guy in Milwaukee I know he put one up and he had some problems, but I think his problem was he had noise sources from all directions, so it really didn't really matter too much. If the noise is in the direction of the received signal, you know, none of these are going to help much. Yeah, Fred.
Gary, you mentioned twice that your K9AY dual loops were put up northeast, southwest. Are they directional enough that you notice a difference putting them up on that angle versus just north, south, east, west?
Yeah, it is. They're pretty broad. One of the things I didn't mention is, assuming I have time, I'm going to take this one down, pull it up rather, and make it east-west, because sometimes I'll get like an African station that's due east, and it's kind of right in the nulls. And they're pretty wide, they're pretty broad, but generally, you know, I'm a contester, so I want to generally move these things to population centers. This one's to Europe, and as a DXer, this, you know, the opposite direction will be, you know, to the Pacific. Japan is not a high QSO number, but it's good for multipliers, so I want to hear those. You don't have to put them that way. This is the way most people are, because most people that do this are DXers or contesters, and these are the areas that they do. If you put it north-south, you know, yeah, you're gonna help in those directions. There's not a whole lot of guys north of us, of course, but it will certainly help you, the guys. But like I said, it's pretty broad.
I was just wondering about how directional the K9AY was, not the regular Beverage.
It's not as directional as the Beverage, for sure, if you want a wider thing. I don't know, there's probably, look online, I'll bet you somebody has run the modeling and show you what kind of patterns they have. I don't know exactly. I would say the 3 dB points are probably close to 70 or 80 degrees. But that, I don't know that off the top of my head. I'd do a search online and see what you can find.
You've been talking about receiving antennas. What do you do for transmitting antennas?
I'm again as a DX or as a contester. I want to work the local guys, and I want to work the distant guys. So I have different antennas. One of my beliefs is you can't have too many antennas. On most of the bands, I have at least 2 different antennas for that reason. So for example, on 160 meters, I have an inverted L. That's the only contest band I only have 1 antenna. On 80 meters, this tower is shunt fed, and I have a dipole here. I have a 40-meter beam here and a 40-meter dipole. I gave a talk last week down in Chicago on antenna angles, and then I talk about having multiple antennas. If you're interested in being competitive, if you can have 2 different antennas, different characteristics, like a vertical and maybe a dipole. The vertical will give you a low angle. The dipole, if it's fairly low, will have a high angle. And a second antenna doesn't have to be really big, expensive. You know, if you got a beam for 20 meters or something like that, you can put a low dipole or maybe a vertical will help with the low angles. But I'm a big believer of having different types of antennas, and that's what I use. Verticals on vertical type antennas on 80 and 160. If I didn't have the 40-meter beam, and long-term plans are to take that down and put a 4-square up, which is a bunch of verticals. That's what I do, but there's probably other options too.
All right, I think we'll hold it there because we're coming up on time. Thanks, Gary, and I think everybody learned a little bit here about low band, very low band receiving antennas.
No, thank you. I hope you learned something.
All right, coming up at 1 o'clock here, we have West Mountain Radio doing some DC distribution. So in that talk, so please come back in a few minutes, and we'll have that set up.